Hello and welcome back. In this video, we are going to focus on the normal distribution, okay? So let's talk about the motivation first. The normal distribution is the most widely used model for random variables with continuous distribution. There are mainly two reasons, okay? The first reason is that it is nice. It is intuitive distribution, unlike, let's say, the gamma or the beta, which we will talk about them later, is harder to understand. Okay, so the first reason is that if normal distribution is easy to understand. Okay, this in my opinion. In contrast to the beta or the gamma distribution that you see in the next few videos. Okay, and the second reason is because of everything converges to normal. Okay, so if let's say so if let's say you did study about the central limit theorem, right? So because of the central limit theorem, this one is nice to use. But for this one, we are going to look at in the chapter 6 in lecture 43. Okay, so stay tuned about the second reason. But these distributions are strange in terms of that these distributions are the ones whose PDF cannot be integrated in the closed form. So that's why it's the table of the normal distribution. Because the computer programs used, let's say, some kind of the numerical solutions in order to compute the property and quantize. And nowadays it is extremely easy. These are not the limitations in using the normal distribution at all, okay? And stay tuned for the lecture 41, okay? Stay tuned for the lecture 41 because in the lecture 41, there will be the surprise for chapter 5. So if you don't want to miss any upcoming video, so I recommend you for subscribe, okay? Because in lecture 41, we are going to throw some surprise for you. Okay, then this is the definition. Okay, I think you all have seen it, but it's not important at all because we are not going to use it, except that you are learning about the mathematical statistics. Sometimes you have to do algebra around this, but for this class, no. Okay, and because we don't have to calculate this stuff because nowadays the computer are extremely fast. Okay, but the matter is that for this kind of strange looking function, how do we know that it's a distribution? That means it is positive, sure, exponential, pi, sigma, sure. But how make it sure that it's a PDF? So I type out the proof here to show you that don't dare do this at home. Okay? If you dare do this at home, I think for 3 days, you realize that you are stuck because you use all the tricks that the calculus instructor has shown you. But let's say we define I to be this one, okay? For simplicity, and we must show it. This one is a trick. If you use all of the calculus class strategy, you cannot solve it. Because this one requires to solve it something like this. We don't know the I, right? We just multiply into I squared. So you may ask, what? Does it work? Usually it doesn't, but this case it does. And this one we get this kind of thing here. But notice something beautiful here. If you learn about the multivariate calculus, okay, this one, it is like the radius right? So you can convert to the xy coordinate, to the polar coordinate. So xy coordinate is something about x, y, right? But if it's the polar coordinate, what we care is theta and the r. These two forms are equivalent to one another. That means if you have x, y, you can convert to polar. The parameters are theta and r. If we know theta and r, we can convert back to the xy coordinate. Okay? And you could get 2 pi. Okay? Don't dare do this at home. Okay? Moment generating function. It is kind of look nice. This why one of the reasons why this is popular. Okay, so you can do this at home. It's a little bit messy. Okay, you can look at it in the textbook. Oh, we have the proof here, right? Okay, good. So for the MTF, we put this. We put this. Oh, I see why I include this, because again, don't do this at home. Okay, don't do this. Don't do this at home. This one is equal to this one, right? And then for this one, this is the same as this one, right? You know what? This one is the same as this one. If you don't believe me, just expand this term and you can get the left term. But how? The answer is creativity. Okay? So don't dare do this at home because of this kind of obstacle that you need to think. But if you get past this one, it's gonna be easy because this we get this one, right? And we get C, and we can pull this out because C is a constant here. Okay. Okay. So the sum of random variables. If the random variables are independent and xi has the normal distribution with mean mu I and sigma I squared, then the sum x1 positive sk is the normal. So this one we should prove with the MTF, right? Because it's not just that, okay, mean is equal to this, variance is equal to this, but we just specify that it is still normal. So you can use the MTF proof by the MTF, okay? But this one you can expand very easily for the mean and the variance because they are independent. Okay? And another thing is the log normal distribution. Log normal distribution is heavily used in finance, okay, because it captures many scenarios. So what does it mean log normal? Log normal is that log x is normal, okay? Log x is normal. And these are the properties of the log normal distribution. So if, let's say, if y is equal to log s, this is the MTF. It's very similar, right? MTF is this term. But what is nice is that this looks messy. But if it's log normal, because it is the exponential of the normal, so the MTF of the log normal looks very nice. Okay, and exponential of x is this term, and exponential is this term, and this is the CDF. So x less than or equal to x, we can substitute to the log x, and we can use this kind of this symbol is the normal CDF. It's a normal CDF. Okay, we just substitute log x. Okay, so I think these are all about the normal distribution. Let's see. Okay, so these are all about the normal distribution, and in the next lesson, let's see what distribution we're going to study next. So stay tuned.